Given question, determine the resultant of a system of forces acting on a beam AB as shown in the diagram.
In this question, we have to find out resultant of all these forces acting on a beam. If we observe, these forces are acting at different points. So we can say that these are the non-concurrent forces, and we have to find out the resultant. So we will first find out magnitude of resultant as well as the direction of resultant. So how to find out magnitude? So first we have to resolve these forces into horizontal component and vertical component. Now the two forces 20 kilonewton and 30 kilonewton are vertical forces, but this 20 kilonewton force is the inclined force and the angle of inclination is given 60 degree. So we have to show that. So here is the angle of inclination. Now how to resolve this force, that is vertical and horizontal component. So here is the point of intersection, that is at this point this force is acting. So I will resolve this 20 kilonewton force at this point. So first I will take horizontal component. So here is the horizontal line. We have to show direction here, and here is the vertical component, and we have to show in downward direction. Now how we can show here the value? So for horizontal component it is nearby to angle 60 degree. So we can say 20 cos 60. So its a value is 20 cos of 60, and this vertical component is away from the angle. So we can say that 20 sin of 60. Now we will find out magnitude and direction of the resultant. So to find out the magnitude of resultant, we have to first find out the horizontal component of the resultant and vertical component of the resultant. So for horizontal component of resultant, we have to find out Rx, and for the vertical component of resultant, we have to find out Ry. So how to find out resultant Rx? That is, we have to add all the horizontal components of all these forces. That is, we have to take Rx is equal to summation of all forces along horizontal line. That is along x-axis. So summation of Fx. And we have to find out Ry, that is the summation of all forces along a vertical line. That is along a y-axis, summation of Fy. So how to find out summation of Fx? So for these two forces, horizontal component is 0 because these two are the vertical force. And for this 20 kilonewton, here is the horizontal component. Now this 20 cos of 60. So we can say that summation of Fx is equal to 20 cos of 60. Now here the main important thing is about sign. Now it is acting towards left hand side. So for left hand side, we will consider negative sign. So we can say that for this towards right hand side, we have to take the positive sign. So when we solve this, then we will get summation of Fx is equal to minus 10 kilonewton. That is, minus sign is there. So we can write plus 10 kilonewton, and we have to show the direction. Direction is towards the left hand side. We have to show this. Now we will find out Ry, that is summation of Fy. So how to find out this? So summation of all vertical component of the forces. So here also sign convention. So for the downward direction, we will take negative sign. So we can take any sign, but for opposite direction, we have to choose opposite sign. And then for upward direction, we have to take positive sign. Now for downward direction negative sign, that means minus 20, minus 30, minus 20 sin 60. When we solve this, we will get negative, that is minus 67.32 kilonewton. So we can write in terms of sign 67.32 kilonewton, and direction is downward direction. So here is the direction. We will find out the magnitude of resultant R. So this R is equal to under root of Rx square plus Ry square. That is 10 square plus 67 0.32 square, and we have to take square root. So magnitude is equal to 68.06 kilonewton. Now we will show this R with the help of diagram. So how to show? So there is one rule. When we take this Ry and Rx, Ry that means vertical component and Rx is the horizontal component. So we have to always show these two forces one after the other. That means at the end point of one force there should be start point of the other force. Now in this case 67 is the greater magnitude than 10. So we have to take vertical component much larger than this horizontal component. So first I will take this vertical component and which is in the downward direction. So we have to draw here one long line because 67 is larger than 10 and here is Ry. Then we have to take Rx. Now at this end point we have to start the second force, that is 10, and the direction is towards the left hand side. So I will show here Rx. Now magnitude is less, that is 10, so we have to show here short line. Now how to show resultant R? So we have to connect the start point of one force and end point of the other force. So I will connect this, and direction is here, that they should meet. Here is the direction and this is the resultant R. Now we have to find out angle of inclination of this R with the horizontal line, that is along the x-axis. So we can say that this is the angle alpha. So we can say that from this triangle tan alpha is equal to Ry by Rx. Tan alpha is equal to Ry by Rx, and therefore alpha is equal to tan inverse of Ry by Rx. So tan inverse of what is the value of Ry? 67 and Rx 10. So when we solve this we will get alpha is equal to 81.55 degree. Now we have to plot here. So we will take the distance of this resultant R approximately at a distance x, because this value is unknown. So I will take here the distance of the resultant, that is the point of action of resultant is at a distance of x from this point A, and I will show here resultant R. Now resultant R is at an angle 81.55 degree. So I will show here. So this is the resultant R. Now we have to find out the value of x. So how to find out? And for this resultant of coplanar non-concurrent forces, we have to apply principle of moments or Varignon's theorem. That means we have to apply here one rule for the moment. So according to this Varignon's theorem or principle of moment, moment of all these forces acting on a system about a moment center is equal to moment of the resultant about the same moment center. So we have to show that moment of all forces about any one center, so we can take here as a point A or point B, about one moment center is equal to moment of their resultant. So this is the resultant. Moment of the resultant about the same moment center. We will apply the Varignon's theorem for this diagram. So we will first resolve this R into two components. Vertical component is known as Ry. So I will take here Ry, and horizontal component we will show here as a Rx. Now we will take the moment about A. So we have to show here moment about A for all these forces is equal to moment of this resultant about the same moment center. Now if I consider the moment of this first force 20 kilonewton, then here is the line of action of force. So if I extend this, then from this A perpendicular distance is 1.5. Now if I move the compass in the direction of the downward direction about point A, then here is this clockwise direction. And for this clockwise direction we will consider positive sign. So how we can say that 20 multiplied by 1.5 plus next 30 multiplied by total distance is 3. So here is also same direction. So 30 multiplied by 3 plus Now here is the vertical line 20 sin 60. So if I move the compass in the downward direction, so here is the same. So 20 sin 60 multiplied by perpendicular distance 3 plus 3, that is 6, is equal to. Now if we observe, here is the horizontal component. Now this horizontal component, if we extend this, then it is passing through the point A. So there is no any perpendicular distance, and this perpendicular distance is 0. So here if we take the moment of this horizontal component, then it will become 0. So we have to take is equal to. Now is equal to moment of this resultant. So for resultant also there are two components. So for the vertical component, Ry multiplied by perpendicular distance. Now here also if I move the compass in the direction of Ry, then the same direction. So we have to take positive sign. So plus Ry multiplied by x. Now value of Ry we have calculated. And if I take the moment of Rx, then if I extend the line of action, then it is passing through A. So perpendicular distance is 0. So we have to use this. Ry value is known, it is 67.3. So value of x is equal to 3.3 meter.